Hello. We will start Unit 4 of our course with the study of capacitance of a conductor. What is the meaning of capacitance of a conductor? Well, tell me, what is the meaning of capacity of a container? This is a container, it has a capacity. I know most of you will understand it as capacity of a container is the amount of substance it can hold. Now, I'm going to define it in a slightly different way. When I pour some liquid or whatever that is into this container, what happens is the height of the liquid in the container increases. Now, when I poured liquid into it, its height is now this much. Now, if I pour more liquid, the height increases. So, as I keep on pouring the liquid, the height of the liquid inside the container increases. So, I'm going to define capacity of this container as the amount of liquid that will raise the height of liquid in the container by 1 meter. How much liquid is needed to raise the height by 1 meter? In other words, you keep on adding the liquid, you keep on increasing the height. That means the effect of adding the liquid is to increase the height. And so we define capacity of that container as the amount of liquid that will increase the height by 1 meter. In the same way, we can define capacitance of a conductor. Now tell me, when you give charge to a conductor, what are you raising? In the case of the container, when you put liquid inside the container, you raise the height. When you give charges to a conductor, you raise its potential. You see? Do you remember the equation for potential of a charged sphere? It is kq over r. You increase the charge, you increase the potential. So, when charges are given to a conductor, it raises the potential of the conductor. As a conductor gets charged, its potential increases. Therefore, how can we define capacitance of a conductor? The amount of charge given to a conductor to increase its potential by 1 volt is called the capacitance of that conductor. So, in the same way as when liquid is poured into a container, the height increases. When electric charges are given to a conductor, its potential increases. The amount of charge that is given to a conductor to increase its potential by 1 volt is called the capacitance of the conductor. Now, we use the letter C, uppercase C, to represent capacitance. Now, what is the unit for measuring capacitance? If you look at the definition, you can figure out the unit right away. It is the amount of charge per unit potential difference. The amount of charge needed to raise the potential by 1 volt. It is coulombs per volt. Is that right? That is the unit of capacitance. Since capacitance is charge per unit volt, we can write an equation for capacitance of a conductor. Capacitance of a conductor is Q divided by V, the amount of charge needed to raise the potential by 1 volt. Charge per volt. Since Q is measured in coulombs and V is measured in volts, capacitance C is measured in coulombs per volt, and it has a meaning, it has a name. coulombs per volt is called a farad. You see, just like a coulomb is a large unit, farad is also a very large unit. That means for utility purposes, for everyday usage, you've got to use smaller units. What are the smaller units? Microfarad, which is 10 to the negative 6 farad, nanofarad, 10 to the negative 9 farad, picofarad, 10 to the negative 12 farad, and so on, are the commonly used units of measuring capacitance. Now tell me, what is the potential of a charged spherical conductor? We talked about it last class also. The potential of a spherical conductor is KQ over R, and if you replace your K by 1 over 4 pi epsilon naught, I hope you know that. K is 1 over 4 pi epsilon naught. I can write the potential of a spherical conductor is Q over 4 pi epsilon naught R, and therefore can you write an expression for the capacitance of a spherical conductor? What is the definition of capacitance? Capacitance C equal to Q over V. So capacitance C equal to Q over V. For a spherical conductor, this V equal to this quantity, Q over 4 pi epsilon naught R. Let's replace this V by this quantity. That gives me the capacitance of a spherical conductor is Q over 4 pi epsilon naught R. And you can see the 4 pi epsilon naught R will go up. Q and Q will cancel. That will be 4 pi epsilon naught R. What does that tell you? Capacitance of a conductor does not depend on the amount of charge or the potential. You see that? In the same way, if you look at this one, what does the capacity of this container depend on? The capacity of the container depends only on its physical dimensions. In fact, if I increase the diameter of this container, I increase its capacity. In the same way, capacitance of a conductor only depends on its physical dimensions. The capacitance of a conductor does not depend on the amount of charge you put in or the potential difference. You see, you increase the potential difference, you increase, if you increase the amount of charge, the potential difference also increases. That means Q over V will remain a constant. Capacitance of a conductor is actually a constant for a given conductor. It depends only on the physical dimensions of the conductor. What does the capacitance of a spherical conductor depend on? It depends on the radius of the conductor. That means if you take a conductor, well, this is not a conductor. Suppose you take a conductor, a spherical conductor of given radius, its capacitance is a constant. It means the amount of charge that this will hold so that its potential is increased by 1 volt is the same. The capacitance of a conductor does not depend on the amount of charge you put in it. Okay. What is a capacitor? Well, so far we talked about capacitance